Hello, welcome to our Strength of Material lectures. Now, in this lecture series, we are basically going to start about plane stress transformation. Okay, so this is going to be a lecture series where we are going to discuss the concepts as well as the example problems. Okay, we will see how to solve the problems and we will also see the theoretical concept behind. Okay, so this is going to be a thorough lecture series on plane stress transformation. Okay, so let's begin one by one. Now in this class, because this is an introductory class, we are going to see what is basically first we will see what is plane stress, and then what we'll see what we mean by transformation, right? So what is plane stress? Okay, now basically when we have a body, a real life body, 3D body, we have stresses in all the three directions. Okay, so in reality we don't have plane stress condition, we have rather space stress condition. Okay, if we can phrase it like that. For example, if we have a body like this, okay, now you will see this is a 3D body, you will see stresses everywhere, okay, on all the faces. For example, you will also see stress here. Now you will also see on the back, right? You'll also see some kind of stress here. You will also see stresses here. So you will see the stresses are everywhere, okay, on all the six faces. Okay, but in the plane stress condition, what we assume at least the stresses in at least one direction are ignored. Okay, we ignore, for example, now these out of plane, we ignore these two. Okay, so whatever we have, we only have the stresses in 2D only. Okay, or that's what we call as plane. Okay, 2D or plane. Okay, so in the plane, for example, if we have condition like this, okay, if this is the normal stress on this plane, this one is the normal stress on this plane, for example. Okay, so if this is the normal stress, okay, so there will be a complementary stress like this opposite. Okay, similarly, if we have a shear stress like this here, okay, then we are going to have a complementary stress here. Okay, and we are going to have things like this. Okay, now the thing is that there is no normal stress here. Okay, we don't have this, we have stresses only in the plane of the paper or the display, as you can see. So this is what we call as plane stress. Okay, we don't consider the stress in the third direction. Okay, or in the simple words, we simply ignore the stress in at least one dimensions out of three dimensions. Okay, so we have understood the plane stress. Now let us talk about plane stress transformation. Okay, now let us talk about this transformation. Okay, now we can understand this transformation, I feel like we can understand it in two ways. Okay, so let me show it here. For example, now what do we mean by transformation? Okay, right, or rather plane stress transformation is basically like when we know the stress conditions in one coordinate system, and what we do, we rotate it. Okay, we rotate the coordinate system, and then we see what is going to happen to the stresses. Okay, so if I show it like this, for example, if we have a plane stress condition here, okay, this is sigma 1, for example, this is sigma 2. Okay, now let us say we have some shear stress, let me call it as maybe tau 1, or rather tau xy 1. Okay, so we are going to have complementary stress like this. Okay, they will be all equal. Okay, now how do we get this? For example, let us say the axis was like this. Okay, the axis is like this. Okay, this is the x-axis and this is the y-axis, and in this coordinate system the stresses are this. Okay, now what we do, we rotate it. Okay, so we rotate it. Okay, Let me show it here. Now this was our original coordinate system. Okay, now we rotate it in, for example, maybe clockwise or in anti-clockwise direction. Okay, then we cannot call this as x-axis right now, okay, because this is rotated. Okay, because we have rotated it, we call it as x dash and we call it as y dash, right? So these primes, x prime or y prime, they denote the rotated coordinate system. Then what is going to happen to these stresses? Okay, so when we rotate it, okay, so when we rotate it like this, right, initially it was sigma 1, so it is going to be sigma 1 dash, right? Now this was sigma 2, it is going to be sigma 2 dash. Similarly, it is going to be tau x prime y prime, okay, or let us call this tau xy, okay, and this one is tau x prime y prime. Okay, let us keep it simple. Okay, so now because we rotated it, right, so we got these stress conditions, state of stress with respect to a new coordinate system, rotated coordinate system, right? So now the question is, what is the relation of sigma 1 prime and sigma 1? What is their relation, right? Similarly, what is the relation of tau xy with tau x prime y prime? Okay, so what is the relation? Okay, so we can find the basically, if we know the state of stress, if we know this, okay, we know the sigma 1, we know the tau xy, okay, we know it. Okay, but remember, it is in xy coordinate system, right? We know this condition. Now let us say we have a question of we have rotated it. Okay, now we rotated it and we got x dash y dash. Okay, we rotated it, let me write like this. We have rotated what? The coordinate system. Okay, so we got sigma 1 prime tau x prime y prime, okay, but in x prime y prime coordinate system. Okay, so we know this and we have to find the these primes in the, basically we have to find the state of stress, the normal stress and shear stress when we rotate a coordinate system. That is going to be that these are the problems usually that we see, okay, that we often see. Okay, we know the stress conditions in one coordinate system and then we rotate it, okay, and then we have to find the the new stress conditions based on the with respect to the new coordinate system or rotated coordinate system. Okay, so this is one way of understanding it, and the other way of understanding it is the plane stress transformation is for example, if we know this state of stress, okay, in one, for example, like this, if we know the state of stress, okay, now we want to find stress on an oblique plane. Okay, for example, this one is a normal plane. Now let me say this is plane 1. Okay, let us say this is sigma 1, this is tau 1. Okay, now we know on the plane 1 it is stress is normal is sigma 1 and the shear is tau 1, right? Similarly here we know, for example, let us say this is sigma 2. Okay, and in this plane 2 we also know the state of stress. Okay, now the question is, what about this plane? For example, let me draw a random plane like this. Okay, now what about this plane? This is also a plane, right? Now this one is a normal plane 1, now 2 is a horizontal plane, and we know the stresses, right? But the question is, if we know the stresses in these planes, how do we find the stress on these planes? Okay, this plane is neither horizontal nor vertical, right? Rather they are in between, and we call them as oblique planes, right? What we call them as oblique planes. Okay, so what are the stresses? Okay, so what is the normal stress on this oblique plane, right? Let me call this as sigma dash. And what is the shear stress on this oblique plane? Okay, let me call it as tau prime. Okay, so we have to find these two. Okay, how? When we already know the stress conditions on this. Okay, so it is only possible in both the cases. Here it is only possible when we know the relation between these. Okay, so when we know these relations, so when we know how to find the one stress condition from the other stress condition. Okay, so there must be some relation, right? So now again there are two methods. Now the question is simply like, how do we find the stress in the rotated condition, right? Or if we know state of stress in one coordinate system, right? We have to find state of stress. State of what do I mean by state of stress? It means to find the normal stress and shear stress. Okay, that's it. Okay, in other coordinate system, right? Other coordinate system. Okay, but basically it is rotated coordinate system. Okay, coordinate system, right? So this is basically what we want to find, right? So in order to achieve this, we can do it two ways. Okay, we can do it in two ways. First, we are going to use we are going to analytically see. We call it as method of equilibrium. Method of equilibrium. Okay, this is one way of how we can find the state of stress in one coordinate system when we already know the state of stress in this. Okay, for example, we know sigma and tau, and we need to find sigma prime and tau prime. Okay, now we know this, right? And we don't know this. Okay, so one method is method of equilibrium. Okay, this is an analytical thorough method. Okay, so basically we analyze it. Now the another is basically we derive some equations based on this method of equilibrium. Okay, and we can simply call it as method number 2. We can call it as equation method. Okay, equation method or method of equations. Okay, now in this we have some few sets of these equations. For example, how do we find the sigma dash, and how do we find the tau dash or tau prime? Okay, how do we find the shear stress in the new coordinate system, and how do we find the normal stress, and how do we find the shear stress? Okay, so we know these equations. Okay, so they are going to be something. I am not going to show them here. Okay, sorry, I don't want to spoil. Okay, now in the method of equilibrium we will analyze it. Okay, so we are going to see, for example, if this is the plane. Okay, then what we're going to see, we are going to see in this plane what is the stress here in this direction, what is the stress in this direction. Okay, and what is going to be the stress here. That is what we want to find. Okay, because we want to find in the oblique plane state of stress on the oblique plane, or state of stress on the new coordinate system. That is one and the same thing, because I have already told you finding stress on the oblique plane or finding stress on for example, let me show you like this. Now if we say we've had to find the stress on this oblique plane. Okay, so but it basically means like first it was like this. Okay, now it was like this. Okay, for example, so if I get it here, I will show you. So this condition is the same, right? So first, all of this, it means this. First it was like this, then what we do, we rotated it like this, right? We rotated it like this, right? So this is what it means. Okay, so the oblique plane, it basically means a rotation, right? Because we have it here, right? this is it, here it is. Okay, I mean this is just one way of perceiving. Okay, and other way, if you don't want to perceive it like this, okay, if you don't want to say, okay man, I am rotating all of this, okay, you don't need to do this. You can simply assume this is, we have one, this one is normal plane, this is another normal plane, and this one is oblique plane, and I have to find the stresses on the oblique plane. I know the stress on this normal plane. Okay, I know the stress on this normal plane or horizontal plane, right? What I have to write here, tau 2, okay, and this is sigma 2, and I have to find what is the sigma prime and what is the tau shear stress prime on the oblique plane. Okay, so this is another way of perceiving it, but in both the cases the question is the same. Okay, this is the question. Okay, this is the question, and we can do it in two ways: the method of equilibrium and the method of equations, and we will discuss it one by one. Okay, so I don't want to keep a long video lecture. Okay, so you can bookmark this playlist. Okay, better watch these lectures in the playlist. Okay, so that you follow up. So this is the method 1. Okay, and this is the method 2. Okay, so in the coming class we are going to see the method of equilibrium. We will see how to do, and then in the more upcoming classes, then we will see some problems, and then we will come to the method of equations, and then we will again solve some problems on this too. Okay, so I think that's it for today. Okay, so if you have any doubts, you can comment or you can contact me. See you in the next class. Thank you.